Now that we know that the light makes fringes, so when the light comes through here, it goes there, you've got constructive interference, constructive interference, constructive interference. Where are these fringes located? So where, compared to here, and since this is the mth order fringe, we've got where is that fringe located? So first we're going to have to make a few assumptions. First one, D, the distance between these gaps here, D is on the order of the wavelength. It doesn't have to be close, it has to be close, just not exactly the same. And next, L, the distance between the screen and D, so L is much, much larger than D. So let's try this again. Let's take our waves, let's shoot them through. So now my waves are coming through, I get constructive interference here. Now let's go up, let's find that second order fringe. Second order fringe is way up there. The path length difference. So now I'm going, so I have one that's going up like that. And that's going to give me a nice triangle. You can see here we've got some real nice geometry going on. So if here's L2 and then here's L1, I know that this is the second order fringe, so L2 is L1 plus a little bit more, so it's got a little bit farther to go, delta L plus delta L. I also have a real nice triangle here. So where is X2? X2 is here. Where is that second order fringe? It's there, which is what I'm looking for. That's that distance X. Oh look, I have a nice right triangle here where X and L, and then here's my angle theta. So the tangent of that angle, tangent of theta, is opposite over adjacent. So now, I got a nice triangle. Let's see if I can figure out some other thetas. Let's take a look at this a little bit closer. So that means I need to separate it and zoom on in. So nicely, I have, let's zoom into there. Right, here it is. Now we've zoomed in. Here's my distance D, right from here to here. And I have those two paths, but now it's so far out there that these path lengths, right, that distance and that distance, are functionally parallel. Functionally parallel. That's what parallel. Woohoo! So here's L1, here's L2. Remember L2 from our picture is a little bit longer than L1 by delta L, but because it's my second order fringe from our previous videos, we know that that distance is 2 wavelengths. So I know that this is 2 wavelengths. Oh look, if this is theta, then this is theta. So now I end up with a triangle that looks like this. That's D, right triangle, and 2 lambda. And I know this is theta. So as I move this around, so the sine of theta is opposites over hypotenuse. Yay, here's the sine of theta. I have the tangent of theta. Where'd my tan of theta go? There's my tangent of theta. If only you could get them close together. Oh wait, because L is much, much larger than D, I get to use the small angle approximation. Yes, so where sine theta is roughly equal to tan theta is roughly equal to theta if theta is small. So now I just get to make them equal to each other. So now 2 lambda over D equals x over L. So I'm trying to find the distance to that second order. So x2 equals 2 lambda L over D. Yay! But what if I want to find the third order, or the fourth order, or the fifth order? Because I have an integer, that integer is just m. So 0, 1, 2, 3, 4, 5. So we can replace that letter with m. So this turns into the position of the mth order fringe is m lambda L over D. Remember, because we're using a lot of approximations, we're going to throw that in there.